Hello, welcome to section 2 of our lesson, the pillars of object-oriented programming. In this section, we will be talking about encapsulation, abstraction, inheritance, polymorphism, and identity. Encapsulation. In this video, we will describe first a problematic situation. We will then introduce encapsulation as a solution, and we will end this video by mentioning the consequences of encapsulation on code. Let's get started. Let's consider first a piece of code to illustrate our case. Consider class A that declares a public double variable. Consider now class B and C that both create an instance of class A, which is used to directly access the variable and change its value. Consider now that there's a change in the requirements, and variable is to be a 4-digit precision double. We would then have to change all the classes that set the value of the variable. We have brought the changes to class B, and here are the equivalent changes for class C. As you might have noticed, we have had to change code in two classes, in two places of our software. This code is a bad quality code because we had to bring changes to several classes for only one requirement. In other words, our code is non-maintainable or difficult to maintain. The consequences of which developers might forget some of the classes that has to be changed and will end up having bugs in their software. To conceptualize this situation, let's go through it again. Class A has declared a public variable. And as the software is being developed, more and more classes create references to an object of class A and access the variable directly. What happened? With the event of a new requirement, for example, the variable is a 4-digit precision double, all the classes that change the value of the variable must be changed. This is the situation we have just looked into. It is a problematic situation because developers had to change code in several classes. Let's consider now a solution to that problem. The solution to that problem would be to have the variable made private and the changing of the value of that variable done inside a method called a setter method, which is responsible for setting the value of that variable. As a consequence, all other classes would go through that public method to set and change the value of the variable. Should there be any new requirements, this would not be a problem because we would have to change code in only one location. Let's take a look at a piece of code. If we are to change class A to make the variable private, to add a setter that is responsible for changing the value of that variable. As a consequence, class D and E are forced to use the method we have called the setter to set the value of the variable. Should there be a new requirement, we would just have to change code in one location. This is a situation that is much better. The code is centralized and easy to maintain. The consequences. Encapsulation is when a piece of code is written once, wrapped in a method, and accessible only through that method. Maintenance of code becomes easy as portions of the software code are centralized. The size of the code will shrink compared to a situation with no encapsulation. Productivity is enhanced as the reuse of code is imposed. The encapsulated code is written once and used everywhere. In this video, we have talked and introduced a problematic situation that we have managed to solve by introducing the notion of encapsulation. We have also talked about the consequences of such practices.